All right, so now we're moving on to 1.6, two-dimensional figures. Okay, again, we've got an awful amount of vocabulary, so make sure you understand the vocabulary, and again, look in the key concepts for what each one of them means. But anyway, the first one is a polygon. A polygon is just a closed figure. Okay, they give you examples down here, look, and they give you the ones that cannot be. So simplest things, anytime you see any sort of curve, you can ignore that. The most obvious one that people mistake is the one that looks like an hourglass. Okay, it's always mistaken, but the moment you see a cross or an intersection, then it's not a polygon. Okay. The other thing you need to know is the difference between concave and convex. Okay, so look for general shapes like this, because think of the last four letters of concave. It's a cave. You go into a cave, so the moment your diagonals from one vertices to another go inside, then it's concave. Anything else is convex. All right, so before we move on to any of the examples and questions, here's a list of all the different names of the most regular polygons that you are going to be using. You know, the three-sided, a triangle, all the way through to a dodecagon, a 12-sided. But anything above that is called an n-gon. So if you've got a 13-sided figure, you just call it a 13-agon, or a 14-agon, or a 50 billion-agon, okay? The other thing is regular polygons, so that means that all the sides are the same length and all the angles. And again, look for notation. Okay, so for instance, all the angles A, B, C, D, and E are all the same by the notation, and all the sides A, B, B, C, C, D, etc. again by the notation. So that is a regular polygon. But remember what we had earlier on in the chapter. If you do not see anything like the notation, or if you do not see anything in the description that says that it's a regular polygon, you've got to assume that it isn't. All right, so then we go on to example 1, and you're naming and classifying it. So let's have a look at A. Just count the number of sides, a 6-sided figure. If you can't remember it's a hexagon, go back to the previous page and you can see that it's a hexagon. And not all the angles are the same, because even though the sides are all the same, this angle is not the same as this guy, so it's an irregular. Okay, and then again, what I was saying before, if you put the diagonals across, you're actually going into this shape, so this is concave. Okay, so it's irregular, it's a hexagon, and it's concave. Okay, so let's have a look at example 1 in its question form. Let's have a look at question number 1. So first of all, you've got to name each polygon by its number of sides. So question number 1 is a 5-sided figure, so it's a pentagon. Okay, what else is it asking you for? Is it's classifying it as concave, convex or concave. Well, from B to C and C to D, you're going in, so that's concave. Okay. And then whether it's regular or irregular, well, you've got no notation, so it's irregular. Okay, so just make sure you work your way through all the questions. It's not just a case of, oh, it's a pentagon, move on to the next question. Make sure you answer all the questions. All right, so here's where we start coming into formulas. We've got this, or I've got this little formula working answer. So every time you see a formula, you need to quote the formula. You need to do a line of working out where you're substituting in the letters, numbers for letters, and then obviously come up with your answer. Okay. And now these are obviously standard shapes. You've got the triangle, the square, the rectangle, and the circle. Sometimes they're asking you for the perimeter, which is on the outside. Okay, that's the outside of the shape. So you've got perimeter for every polygon that isn't a circle, and for the circle and the circle only, it's classed as circumference. Okay, and then you've got the area of each. Now for each of these, they've given you the formula for the perimeter, and then for the same shapes, they've given you the area. So all you've got to do is quote the formula, put your line of working out in, and then solve it. Okay, now the only thing to be careful on is the circle, because you've got pi in there, which is 3 1/7, 22/7, or 3.14 recurring. It's an irrational number. Sometimes the question will ask you to use your calculator, the calculator button, your pi button on your calculator, or sometimes it will tell you to use 3.14 or something like that. But make sure you read before you decide which one of those you have to do to answer that sort of question. So here's example 2. So you've got to find the area and the perimeter. And as you can see, the first one, we've got a rectangle. So the perimeter of that is 2 times the length plus 2 times the width. Substitute in L and W and then come up with your answer to, again, whatever degree of accuracy. Sometimes it will ask you to the nearest whole number, to the nearest tenth, which is 10.6. Or if you're looking at the circle, they're using the pi button. The radius is 3 for the circles. Don't forget, this guy is the radius. 18.85, so that's the 2 decimal place, or the hundredth. So be careful. Sometimes the question will ask you to the nearest whole number, or whatever decimal point, or what degree of accuracy. So make sure you answer the question to the degree of accuracy that they've requested. So now we're in example 2, which is question 6, 7 and 8. It's asking you for the perimeter and the circumference of each figure. So let's have a look at what we've got. Okay, so question number 6 is a square. So you've got 4 sides, so don't forget it was 4 times s, so 4 times 11, which will give you 44. And don't forget that's a distance, so it's just feet. Okay. When you're doing area, it's s squared, that's what they've given you. All right, so this time it's 11 squared, which is 121, but this time it's area, so this one is feet squared. So make sure you answer it to the degree of accuracy that they want, and make sure you put the units in. Okay, I'm also going to do number 7. For the perimeter, or the circumference of this is pi d. Okay, so C equals pi d. So this is pi times 12.8. So 12.8 times pi, you're looking at 40.2. And again, that's just feet, or centimeters, I should say. Okay, and then again, this time it's changed. So this time for the area, so area equals pi r squared. So this time we're doing the radius. Okay, so that's pi times whatever the radius is. So half of 12.8 is 6.4. So it's going to be 6.4. We're going to square that and times that by pi. So the area this time is going to be 128.7. And again, it's centimeters squared. Okay, so now for examples 3 and example 4, what you're going to do now is do exactly the same thing as you have done in example 2 in the questions. You're going to be finding the area and the perimeter depending on which of the questions it's asking you for. But anyway, what's it asking you for here? It's asking you that Yolanda has 26 centimeters of cording to frame a photograph. Which shapes would use most or all of it? So you've been given a choice of 3, A, B, C, D, a right-angled triangle, a circle, a rectangle, and a square. Okay, and what you have to do is you have to go through each and every one of them to come up with the area. So for instance, the right triangle. Now what's the first thing you've got to do? You've not been told what the hypotenuse is, so to find the perimeter you've got to use Pythagoras. So you've got the formula, line of working out and an answer, and simplify your answer. Okay, then you're going to find the area of it as well. So we've found the perimeter and we've found the area. And then obviously you've got to do exactly the same thing with the other 3 shapes. So you've got the circle, the rectangle and the square, and then eventually you'll come up with the answer that they are requiring. And then finally moving on to example 4, again, what's the extra bits you've got to do this time? Well, this time they've given you coordinate geometry. So the first thing, the best thing to do is to plot it. Okay, so here they've given you a shape, or, they've already given you the shape. If you plot it, but you don't know by the sides. Unfortunately, this is at an angle. If it was a rectangle or a square that was vertical and horizontal, you could have just counted. But in this case, what you've got to do is the distance formula we did earlier on in the chapter, in order to find out what each length of each side is. So by the time you've done it 4 times, you'll see that all 4 sides are 4.24. So you know it's a square. So all you're going to do then is multiply them by itself.